In this chapter, we're going to look at subtraction of common fractions. Just as with addition, fractions must be expressed with common denominators before subtracting. Subtract the numerators and express the difference over the common denominator. Difference is a term we use for the result of subtraction, okay? Just as though sum is the result of addition, a difference is the result of subtraction. So let's subtract these two fractions. They do not have common denominators, so we will need to find common denominators. And 3 is a prime, so 3 is made up of itself and 1. And 2 is a prime, it is made up of itself times 1. So the lowest common denominator is remember, the greatest number of each prime factor that exists in either one of these. So the greatest number of 3's that exist is 1, and the greatest number of 2's that exist is 1. So the lowest common denominator is 6. So I should convert these into sixths. Okay. Now, what does 3 get multiplied by to equal 6? Well, it's multiplied by 2, so I should multiply this by 2 also. And what does 2 get multiplied by to equal 6? Well, it's multiplied by 3, so I should multiply the 1 also by 3. And now we can do the subtraction. Keep it as sixths, and we do 4 subtract 3, so this is 1/6. In the next example, we are going to look at subtracting a fraction from a whole number. Remember to express the whole number as an improper fraction with a denominator common to the denominator of the fraction. So we want to express my 5 whole, which is 5 over 1, if you want to see it as a fraction. We want to express this in thirds. Well, 1 times 3 is 3, so I must multiply by 5 times 3. 15 thirds, well, 15 divided by 3 reduces to 5, so 15 thirds is another way of saying the whole number 5. So 15 thirds, subtract 2 thirds. Now we just subtract the numerators. 15, subtract 2, leave it in thirds. 13 thirds. Just as a practice also, convert this to a mixed fraction. Remember, you will ask yourself, how many times does 3 go into 13? Or what is the closest multiple of 3 to 13, but not going over? So 12 is the closest multiple. 3 times 4 is 12. So this is equal to 4 wholes. That's 12 thirds. And 1 more third to get the mixed fraction. Let's continue trying, and we'll try this other one. How about you pause the video and try to do this with the same process as the last one. Express the 6 over 1 as a number over 16. So 6 over 1. What is that as an equivalent fraction over 16? We must multiply by 16, so I must do the same up here. 6 times 16 is 96. 96 sixteenths subtract 3 sixteenths is equal to 96 subtract 3, still keep it over 16, which is 93 over 16. Now, let's convert this to a mixed number. So I've got the whole number 6, and you can even picture that as 6 on your tape measure. And we want to back up 3/16. So 3/16 is less than 1, right? It's a proper fraction. So we're not even going back past 5 because we will be between 5 and 6. So this answer will be 5. And I took 3/16 off of the whole. 16/16 is a whole. When you take 3/16 off, you are left with 13/16. So that's another way to visually get that, all right? If we are here at 6 and say this is 5, here's my half, my quarters, my 8ths, and my 16ths. We are at 6 right here, and we want to subtract 3/16. We're going back 1, 2, 3 to here, and there. So this is 5, and we would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay? As you get used to it, you will see that if you're going to count the 16ths, that the largest marker is half of 16. That's 8/16. So I don't have to count them all every single time. It's really good if you can just get used to this. Next, how about a mixed number subtracted from a mixed number? So let's take a look at it before we get started. All right. We have 7 wholes. We need to take away 2 whole from that. We are a little bit above 7, 7 and 5/8, and we want to take away 2 and 3/8. Well, picture that tape measure again. First, just subtract the 2. 7 and 5/8, subtract a whole 2, would put me at 5 and 5/8. So this can be rearranged as well. So this is equal to 7 and 5/8. Subtract 2. I'm going to do that first, and then we will still subtract 3/8 from it. This is only one way for you to look at it. You don't have to do it this way, but if this makes sense to you, then this will work. So 7 and 5/8, subtract 2 wholes. I'm just taking 2 away from 7. This leaves me with 5 and 5/8. And we still need to subtract 3/8. Picture that tape measure, 5 and 5/8. If I subtract 3/8 from that, I'm still above 5, right? Because 3 is less than this 5. So 5 and 5/8, subtract 3/8, leaves me with 5 and 2/8. Or more commonly, we would call that 5 and 1/4 reduced, right? So this worked out nicely because that 3 is less than this 5. So this fraction is smaller than this one. When it's not, sometimes you need to borrow. An alternative method to figure this out, let's just do it another way, is to convert each fraction to improper. So let's convert, let me just write down the question again. 7 and 5/8, subtract 2 and 3/8. It's a really good idea to kind of look first and make sure that this number is less than this one. We're not going to go negative. That's true. All right, convert to an improper fraction. That's 8 times 7 plus 5. So that is 56 plus 5. We have here 61/8. Subtract. And then we do 8 times 2 plus 3. 8 times 2, 16, plus 3 is 19/8. And now we just have to do the numerator, 61 minus 19 over 8, which is 42/8. And now I just need to convert that to a mixed number, and I can ask myself, well, how many times does 8 go into 42? What's the closest multiple of 8 to 42 but not over? Well, 8 times 5 is 40. So 8 times 5 is 40. 42, subtract 40 leaves me with 2/8. All right, so that's a different method. For one more here, we want to first take a look at a situation where we would need to borrow, and that is because the first fraction is actually less than the second one. So 3/8 subtract 7/8 would put us into the negative. So let's actually look at how we can borrow to do this. My 3/8, the problem is that 3 is lower than 7. So if I want to borrow, think of your 10 and 3/8 as 9 plus 1 and 3/8, right? So I've borrowed a whole, and then it will be 9, but this should be improper. So that is 8 times 1 plus 3. We got 9 and 11/8. Now, if I do 9 and 11/8, subtract 5 and 7/8, I've solved the problem of the first fraction being less than the first. We've added a whole to our 3/8. 3/8 plus 8/8 is 11/8. And now, if you want, you can subtract the wholes. 9 subtract 5 is 4. And 11/8 subtract 7/8 leaves us with 4/8, or 4 1/2. All right, an alternative method, in case you like it, is to convert both to improper fractions first. So let's do that way. We'll see it another way. 10 and 3/8. Subtract 5 and 7/8. All right, convert both to improper first. 8 times 10 plus 3. That becomes 83/8. Subtract 8 times 5 plus 7. 8 times 5 is 40. 40 plus 7, 47/8. And now we just subtract the numerator. Keep it over 8. And if they weren't common denominators, we must convert that to fractions with common denominators. And this turns into 36/8, which is an improper fraction. And so ask yourself, how many times does 8 go into 36? 8 times 4 is 32. That's the closest. 32. 36 subtract 32 is 4/8, or 4 1/2. And the same result as we had the other way. Okay, so those are some examples of doing subtraction with fractions. Please give them a practice. Keep in mind this idea of borrowing the whole to make the subtraction easier. Okay, thanks for watching. Bye for now.